Yes.
Let's have this assumption, okay? Assume we keep all the effective parameters constant, except the position of nozzles.
So you mean the height of the nozzle?
Yeah, of course. Okay. But no changing the direction. Still parallel with the graph.
Yes.
How does it make differences in your processing, governing process?
So normally it's no difference. The only difference which we can have with a very big height, there will also be some forces on the forward wheel because we have no drag force on the middle of the car.
So the correct answer would be no principal differences.
Yes.
Valentin?
Please show me the plot of distance against mass.
Distance against mass.
Here.
What can it be, for example, for 10 kilograms?
Sorry?
I think that the question would be about the limit of the graph.
The limit of this plot.
So if you
Yeah,
go
of
to
course.
very high masses.
When the rolling friction, it depends direct on the mass. When it's equal to the propulsion force, the
Please
distance
stay
will be
brief.
zero.
So what is the theory expression, please?
So this graph is only valid when the friction force is smaller or equal is greater than the propulsion force.
Can you show?
So I think that the question would be whether you can show the equation. Maybe they can search for that, and in between we have another question. Andrzej?
Can you show us your slide with a sketch of the car?
Sketch of car. So you mean
This one.
this? What? No, I think this.
Okay.
This one,
Yes.
It's a friction force.
Yes, of the rolling friction.
Yes. Where is the attachment point of this force? To which point it is really attached?
We have in principle we have two friction forces. We have the rolling friction and we have another friction force in the axle of the wheels. But we can simply add this two friction force and we do not have to split it up in these two friction forces. It doesn't matter. So in principle you would have two errors of force.
Okay. I have one question concerning the balloon itself. So that you have a dependence between volume and pressure in the balloon for the process of letting the air out, so inflation of the balloon.
Yes.
Would you expect that the graph would stay the same or approximately the same for the process of inflation of the balloon?
No, the graph would be with a higher pressure because
Okay. But then I ask, wouldn't it be more appropriate to take the graph for the inflation process because you wouldn't want to measure the energy which is given to the balloon?
Yes, it is a point, but I needed the graph, the pressure curve also for the velocity of the expelled air. So in principle I could take here two different pressure curves, but I decided for this one because I think it's more important here.
Samuel?
I have a question to the opponent. You mentioned or asked the reporter whether there is a difference if you have high speed of airflow in a short time or a low speed over a longer time. So what do you think? What would be better?
High speed over a short time or low speed with longer time?
Yes.
So I think for the distance it would be better for the small speed with longer time.
Can you give a very short explanation why you think so?
So like when the car is moving at a small velocity, it will experience a smaller air resistance. So that and also when the propulsion force is small, it means that it will experience the force for a longer time. So I think it can be concluded that in that sense, the car's distance travel will be maximized.
Okay, thank you.
Okay, thank you. Further questions? A bit more time. Okay, if not, then thank you very much once again, and we will eat some time. Now, please, would you show me the grades for the report now? And it's an 8, 7, 8, 8, 7, 7, 8, 7, 8, 7, and a 7.
A Alza conseguiu muito mais 8.
Grades for the opponent.
Conseguiu uns
Now.
3, conseguiu uns 4, 8 brincando, a Alza.
It's an 8, 8, 8, 8,
Mereceu 7, 8.
8, 8, 9, 9, 8, and an 8. Thank you. And the grades for the reviewer now. It's a 9, 8, 9, 9, 9, 7, 8, 9, 8, 8, and an 8. Thank you very much.